I have another example listed up here. It's quite a bit more complicated. The polynomials are more complicated. But again, just remember, focus in on one polynomial at a time, factor it as much as you can, and then try to cancel the common factors from the top and the bottom. In this first polynomial, this one actually has two variables in it, so we'll just got to be a little bit careful. In this top polynomial here, you could think of it without the y's in there, or you could think of it with the y's, doesn't matter. It is a trinomial, and so as a trinomial, we either have the AC method, the modified AC method. This one has a lead coefficient of 1, so we wouldn't even need those. We could just do that shortcut. Or we could do a perfect square trinomial formula if it fits one, and this one actually does, because if you take the two things that are being squared, the x and the y, and double their product, you get the term in the middle. Okay, so this is pretty obviously a perfect square trinomial, and so is the bottom. So I could rewrite this in factored form as x plus y quantity squared on top, right? The bottom one has this minus in the middle, so it is x minus y quantity squared. Or you could think of the top as x plus y times x plus y, and the bottom is x minus y times x minus y. The second fraction, here we have a common factor of 4. So I pull out the GCF, I get x minus y. And here I have a common factor of 3. I pull out the 3, I get x plus y. Okay. Now I cancel any common factors. Well, here I have an x minus y on top, and I have actually two copies of x minus y in the bottom. It's like having x minus y times x minus y. If I cancel one of them off with this one, I'm only left with 1 on the bottom. So it's like reducing powers. Remember when we did our exponent rules, when you have a factor on top and bottom with powers, you reduce or subtract the powers. That's what we'll do here. So subtract the 1 and the 2, and you'll end up with a 1 on the bottom. And we can do the same sort of thing. Think of this as a 1 with the x plus y. So you've got 2 on top and 1 on the bottom. You cancel 1 out, you end up with a subtraction or a difference in the powers. So we'll be left with, this cancels off with one of those, and this cancels off with one of those. Okay, so we're left with x plus y, x plus y, there we go, times 4. I'll put the 4 in front just because it's a kind of a common notation to write the constant in front. Doesn't matter though. And then here I'm left with an x minus y, and I'll throw this 3 in front. That's it. This would be a sufficient answer. I would take this answer. You could also pretty easily distribute the 3 and the 4 in. It doesn't really matter. If you wanted to, then you'd have 4x plus 4y all over 3x minus 3y. Okay, so either of these answers is sufficient. For my standards, I think my math lab will keep it factored again, but on these simpler ones, sometimes my math lab is a little funny and we'll distribute it out. So it just depends on what you have, or what the instructions say, I suppose. Okay, that's good for multiplying, I think, but let's now look at division a little bit. Division with numbers, remember, is not that far off from multiplying. Division with numbers is not that far off from multiplying. So, like if I had, let's see, 2 over 5, and I was dividing that by 1/4, well, dividing by 1/4 is the same as multiplying by 4 over 1, right? So when dividing, we multiply by the reciprocal of the second one. I often call this a copy dot flip idea, or copy dot flip method, okay? And so I would copy the first fraction, change the divide to a times, and then flip the second fraction. You're multiplying by the reciprocal. Then you just go through the multiplication process that we just saw. So it's not really any different except for that first step, which is just rewriting it down by flipping the second fraction. And so here we just end up with 8/5, okay? Now, of course, if this reduced, we'd want to reduce it first before multiplying. But really, there's not any difference between dividing and multiplying, except for that first step of flipping the second fraction over. Okay, so that's what we're going to do. Same thing, same principle with rational expressions. Okay, so I'll grab a couple examples off the book here. We could do something like x squared minus x over 15 divided by x minus 1 over 5. Okay? Again, it's a division problem. My first step should be copy dot flip. Okay, so that would be copy on the first fraction, change to a times, and then flip the second fraction. That's it. I'm not going to do any factoring first. I'm not going to do any canceling. In fact, if I try to cancel, I'm going to get it wrong almost certainly. So with division, you just take this first step, be patient with it, take the first step, copy dot flip. I know you have to rewrite the problem, but whatever. And then you go through and do the factoring and the canceling and multiplying. Okay, so at this point I factor. X squared minus x has a common factor of x. I'm going to pull that out. Remember, always look for GCFs first before anything else. Here's a GCF. If I pull that out, I'm left with x minus 1. Bottom is 15. Well, I'm going to be a little sneaky about this. I already recognize there's a 5 over here, so I'm going to write the 15 as 5 times 3. Just helps my mind mentally to see what's going on. Then in this other fraction, I have a 5 and an x minus 1. Now I can do some canceling. Remember, you have to cancel entire factors. Well, I have a 5 that's common to the top and the bottom. Those can cancel. I also have an x minus 1 that is common to the top and the bottom. Cancel out the entire factor. All that I have left on top then is an x, and all I have left on the bottom is a 3. X over 3 is correct simplified form. Okay, so this complicated division just simplifies down to x over 3. All right. And of course, with division, they're all basically similar to this. You just do a copy dot flip, then factor everything out, and cancel what's common. Okay. Maybe I'll do one more that's a little bit more complicated. And we'll call it good on division after that. So let's try, I really want to get something with a modified AC in it. There's one. Let's try that. 8, this is a good one. 8x cubed minus 1 over 4x squared plus 2x plus 1 divided by, where am I? Which one was I doing? That one there. X minus 1 over, x minus 1 squared. That's interesting. Okay, well, it works. Let's try it. So we got a factor. This first one is a difference of cubes. I notice that's a cube, that's a cube, the 8 is a cube. Everything's a cubed up here. So remember we had those difference of cubed formulas. What's kind of interesting, when you guys take a test on this stuff, I'll include the difference in sum of cube formulas on the test. I'm not going to expect you guys to memorize those, but all the other ones, the perfect square trinomial and the difference of squares formula, I'm going to expect you guys to know, so I won't be giving you those. But the ones I will give you are the difference in sum of cubes. So here, if you have a cubed minus b cubed, remember that factors into a minus b times a squared plus ab plus b squared. Okay, so that's going to be your difference of cubes factoring formula. The sum of cubes I would put up there if we needed it. So this is a difference of cubes, and of course in this case the thing you're cubing in the first term is 2x, right? It's essentially the cube root of that term. The b is what you're cubing for the first term. It's the 1. It's the cube root of that second term. Sorry, second term, not first term. And so when I plug those into the formula, my numerator, I'm going to have 2 terms followed by 3 terms. I'm just going to structure that. My two terms are going to be a minus b, that's 2x minus 1. My three terms are going to start with an a squared. Well, you square 2x, you get 4x squared. You get ab, well, ab 2x times 1 is just 2x, so that's plus 2x. And then b squared is 1 squared, which is just 1. Okay, here, 4x squared plus 2x plus 1, I want to try to factor that. It is a trinomial. Leading coefficient is not 1. If I were to factor that, think about this. The AC, 4 times 1 is 4. I know some of you are recognizing something. I'm going to hold off on giving away the spoiler here. So 4 times 1 is 4. Factors of 4 that add up to 2. Well, you get 1 and 4 and 2 and 2, and that's it, right? None of those add up to 2. So this is actually going to be prime, all right? Because it's prime, I just rewrite it down. 4x squared plus 2x plus 1. I can't factor it, so I don't have anything to do with it. I can't change it. However, it's nice because I see something common. We'll come back to that, okay? Oh, booger. I violated my own instructions, didn't I? The first thing I'm supposed to do is copy dot flip, right? Okay, so you guys are probably seeing that. That wasn't even what I was talking about a minute ago. Copy dot flip every time. Copy dot flip before you factor. It should be before you factor. I got a little ahead of myself. I'm going to go ahead and dot this and flip. Boy, oh boy. Okay. I could edit the video and not show you that mistake, but I'm going to go ahead and leave it in there just because. Okay. So I get x minus 1 squared on top, x minus 1 on the bottom. So I just did the copy dot flip, but when I copied it, I factored the first one. Be careful. Again, it's best to do those in two different steps because I've seen people try to factor it out as they do the copy dot flip, and then they forget to do the flip, or they put some things in the wrong spot. So it's just really easy to make a mistake there. All right, I'm rambling. Now that we got that done, let's take a look at what we can cancel. This 4x squared plus 2x plus 1 will cancel with the one on the bottom. So I'm going to go ahead and do that. Right there and right there. Nicely done. In addition to that, I have an x minus 1 squared and an x minus 1. 2 copies on the top, 1 on the bottom. I can reduce the 1 on the bottom with one of the ones on top. So I won't have a square on top, I'll just have x minus 1. I also have the 2x minus 1 left over here. So when I go through and multiply these together, I'm going to be left with 2x minus 1 on top. Also an x minus 1 on top. My denominator has nothing left. You really always have a 1 when you cancel everything off of those of the same side, right? So in the denominator in this case, everything's gone. We really consider that as being a 1. So if you think of it as being divided by 1, well, dividing by 1 doesn't really do much. It leaves it the same. So we're not even going to bother writing that in, okay? So just these two polynomials multiplied together would be sufficient for an answer. We'll go ahead and put a cloud around that one. And there it is. That's our answer. Now you could, of course, expand this out, distribute, multiply that. I'm not going to worry about showing you that. This would be sufficient then for this division problem. Again, copy dot flip, in theory, before you factor, which I failed to do. Then you factor, then you cancel, then you write out your final answer and multiply them. Okay? Awesome. I think that will pretty much cover our multiplying and dividing. We'll move into adding and subtracting in the next video.